Good day, grade 11s. Today we are going to be doing grade 10 revision for exponent rules, and we will be doing some examples at the end of this video after we have just revisited all these rules. So the first rule we are going to look at is the first one over here, which is number 1. So I color-coded everything such that we'll have the bases in red, we'll have the exponents in green, the mathematical system, like the multiplication, division, and equal sign, brackets, and all that stuff in black, and the constants will be in blue. So just take note of that. And the signs will be in purple. Number 1, this is the addition of exponents. So if you are multiplying two variables with respective exponents, but the bases of those variables are the same, then you will be able to add the exponents together. So x to the power of n multiplied by x to the power of m is equal to x to the power of n plus m. For the second one, it's the other way around. So instead of when I multiply these two together, when I divide them together, or if I put them in a fraction, so it will be in a fraction, it would actually be x to the power of n over x to the power of m, we will get a subtraction of those exponents. But obviously the base has to be the same. So that will be the subtraction rule when it comes to exponents. Number 3, x to the power of n all raised to the power of m. So the parentheses over here are separating the m and the n, which we can write this as x to the power of n times m. Look at the order that I have it over here. Okay, so when you see the n first, you'll put it first here. When you see the m here, we'll put it second. That is what I would have said if it wasn't multiplication. So let's understand multiplication. Remember that within multiplication, it is commutative. Commutative meaning if I take 3 multiplied by 2, that is going to be 6. But what if I swap the order around and say 2 multiplied by 3? That's going to give us 6 as well. Meaning regardless of whether you change the order, apologies about that. So, okay, it is recording. So, no matter the order we have these constants, it will still result in the same answer. Therefore, what I'm trying to imply is that if we have n multiplied by m, we can also say m multiplied by n within the exponent. And if we want to convert it back to bracket form, we'll have x to the power of m all raised to the power of n. So we can actually manipulate it. So we can even just go ahead and say that we can work from this step all the way to this step, meaning we can swap those variables around. So we are allowed to interchange these around. Okay, and now that we have that one out of the way, we can work on the fourth one. So with the fourth one, we have the division of exponents, but we are going to convert these divisions to surd form, or you can say the root form. Surd form is the most appropriate way to say it. So right now, if I say x to the power of n over m, this is just going to be equal to where we have the mth root of x to the power of n. Now notice that every single time we see the top, the top of the fraction, right, for the exponent, it'll always go with the base within the surd. But notice that whenever the m, or whenever there is some variable at the bottom of the fraction within the exponent, it will always go outside. It will be the main component of the surd. So it'll be the mth root. So for example, if I say over here, 3 to the power of 4 divided by 2, this is just going to be exactly the same as, because the 2 is at the bottom, that will be the main root. So it's the square root, right? You could do this, but you don't have to. But I'm going to just do it for example purposes. The square root of 3 to the power of the top, which is going to be 4. Okay. So that is how it actually works within the division side of exponents. Okay, and now moving on to number 5. Number 5 is the distribution method. Now, x over y, we added y now as a variable. Notice it's still in red because it is still considered a base. X over y, all raised to the power of n, right? Let's get back to the pointer. is equal to x to the power of n divided by y to the power of n. Meaning, we are going to just say that we are going to take this exponent into this base here, and also into the base at the bottom of the fraction. And then that is what we get as a result over here. So that is that property. There's not much to explain about that. It's just the distribution property. Number 6 is when we have negative exponents. Now, usually students get confused with this, but it's really not that bad. And that is why I color-coded everything, so everything can make more sense. We have a coefficient or a constant in front of the x, right? So it's a multiplied by x to the power of negative n is equal to, and now what you notice, we want to convert this negative exponent to a positive exponent, okay? And in order for us to do that, we're going to take the coefficient, put it on top in a fraction, and then take the base with the negative exponent, take it to the bottom of the fraction, and just flip the sign. Not that crazy. If I were to put this in a different example, and I were to say 3 multiply, so I'll just say 3y raised to the power of negative 5, right? Let's write that a little bit neater. Negative 5. This is just going to be the same as, do you notice? The coefficient is going to go to the top, so it's 3 divided by, or 3 over y, the base stays the same, but notice it's a negative exponent, we want to convert it. So now it's going to be positive 5, or you can just say 5. So that is how we actually just do it. It is not that crazy. Now with the final one, notice that we have x to the power of 0, not x degrees. It's not degrees. I tried my best to make it a bit of a longer circle, so an oval shape, to make it look like a 0. Anything to the power of 0, or x to the power of 0 in this example, is equal to 1. If you raise anything to the power of 0, then you will get an answer of 1. But notice that there is a restriction. If we have a base which is equal to 0, and the exponent is also 0, such that we have a 0 to the power of 0, it'll be undefined. So that is why we have a restriction saying that you can have anything raised to the power of 0 to be equal to 1, except when the base is 0. And that is when that property works. And that's about it for the revision for the exponent rules. Let's go straight to the examples. Okay, so the first example we have here is to simplify 10 to the power of 2x multiplied by 3 to the power of 2x, all divided by 25 to the power of x multiplied by 6 to the power of 2x minus 1. Now, what we need to remember is that all of these values need to be shown in their, prime factor form. Meaning, we need to see, okay, so obviously 3 is a prime number. So we don't need to convert that. But how are we going to convert these values to prime factors, or to its multiplying prime factors? Now, if you have a calculator, or if you're allowed to use a calculator, you just need to take your calculator, press any number. So for example, for 10, okay, so let's start over here. For number 10, we are going to have 10, which will be written as 2 multiplied by 5. All you need to do on the calculator is you need to say the number 10. So write down 10 on the calculator, press shift. If you have a Casio calculator, press shift, and then look for a word that says fact. If it says fact, then you press that. Wait a minute, hold on. Oh, there goes my order. It is not that order, but the order will be you press the number, then you press equals, I'm trying to actually remember it out of my head, by the way. I don't even have my calculator on me. I don't use calculators for beta, but yeah, you press the number and then you press equals, and then all you need to do is then press shift and then fact. Then that is when it will factorize and find the prime factors of that specific value. So if you were to press 3 and press equals and then shift fact, you'll just get 3, because obviously it's just a prime number. If you take 10, press equals and then shift fact, you'll get 2 multiplied by 5. So let's just keep going and then see where this goes, okay? So 2 multiplied by 5 is the prime factors of 10. Raised to the power of 2x, don't forget about that, all multiplied by 3 to the power of 2x. Okay, and then we're going to say this is all divided by 25. 25, what is its prime factors? Now notice that in order for us to get 25, if you do put it in the calculator, you are going to get 5 raised to the power of 2, right? Because 5 multiplied by 5 gives you 25. And this is raised to the power of x because that is our exponent outside, okay? Multiplied by, what is the prime factors of 6? If we take 2 and multiply it by 3, right? And then we'll have 2x minus 1. And now what we need to do is we need to find a way to progress further. Now what all we need to do, if you remember the exponent law where we had x raised to the power of n, or I can say here x over y all raised to the power of n, we had the following. We could just say that we have x to the power of n over y to the power of n. But now we have multiplication, and it actually works exactly the same with multiplication. So if we say x multiplied by y, then this is just going to be the same as x to the power of, and I forgot about the exponent, we're going to have x to the power of n multiplied by y to the power of n. I would recommend maybe converting this to multiplication form and then trying to see if it gives you something along the same as this. And it should be able to. And that should be the reason why this works. So yeah, anyway, we can get this out of the way right now. Let's continue. So what I'm trying to imply here is that this, also I'm going to put the equal sign next to each other just because of space. All we need to do is we need to simplify here. So we're going to distribute, essentially, we're going to distribute the 2x over here and over here. And then what we're going to do, we're also going to just keep the 2x here by the 3, and then we are going to distribute the x into this, right? Or we're going to use the multiplication law, and then we're also going to distribute this exponent into those two values. So it's going to look like this. It's going to be 2 raised to the power of 2x multiplied by 5 to the power of 2x multiplied by 3 to the power of 2x, and this is all divided by 5 to the power of 2x because we're using the multiplication law. And then this is multiplied by 2 to the power of 2x minus 1 multiplied by 3 to the power of 2x minus 1. And then from here, we just need to do the following. And I'm just going to do it over here, okay? So we're going to have this. It's going to be 2x, or 2 to the power of 2x. I'm going to do it in this order, right? All these bases, I'm going to just put them in from lowest to highest. So you're going to see here, it's first going to be 2, then it's going to be 3, then it's going to be 5. I'm just going to do it in that order so it's actually easier to see everything. 2 to the power of 2x multiplied by 3 to the power of 2x multiplied by 5 to the power of 2x. And just to cure the boredom over here, I'm just going to skip to where I put all of it in. Alrighty, and now we are back over here, okay? I just saved your life. I saved a bunch of time over there for you guys. So here, notice we have it in order. And now, what I want you to take note of is now we can break these up. Do you notice that all of them are just multiplying each other, okay? So because they are multiplying each other, we are allowed to do this, right? We can take this part of the fraction, and then we can take it and then multiply it by this part of the fraction, and also multiply it by this part of the fraction now, okay? And we are allowed to do that because it's multiplication and division only. There's no plus or minus sign, but we'll get to that in the next video, okay? But for now, we are allowed to do this. So essentially, it's going to look like this. Boom. Here it is. So now that we just split them up, we can use our exponent laws of subtraction, because do you notice that we have 2 as the base for this one here, and now we have exponents over here. So let's do that, right? So I can just guide you through here. It is going to be 2. Remember that 2 shares the base. Let's go back to these exponent laws right here. When we're going to work the other way around. So notice that what we have, or I guess we can start here. It's x to the power of n divided by x to the power of m. Or we can say x to the power of n over x to the power of m. Meaning we're going to take the exponents, the top one, and we're going to minus it with the bottom exponent. So that is essentially what we're going to do, and we're going to keep the base the same over here. It's going to become one base again. So this is what it's going to look like. It's going to now be 2 raised to the power of the top, which is 2x minus, and don't forget your brackets, 2x minus 1. Okay, so that's top minus bottom, multiplied by, now we're going to work with a 3. So we're going to have 3, and it's going to be the top 2x minus the bottom, which is 2x minus 1. Don't forget about the bracket. And then multiplied by the last one, which is 5 as the base. And let's just, I know it can cancel out and everything, but just for example purposes, let's just look at it like this. 5 to the power of 2x, which is the top, minus the bottom, which is also 2x. And then this tells us here that this is going to be equal to 2 raised to the power of, we can actually take the negative into all of this, so I'm just going to skip to the part, well, I guess let me just do it right now with you guys. 2x minus, the negative goes in, okay, over here to both of these, minus 2x, and then the negative and a negative cancels to give a positive 1, multiplied by 3 to the power of 2x, minus, the minus goes into the 2x, and the minus goes into the negative 1, which gives you a positive 1. Multiplied by 5 to the power of 2x minus 2x is just equal to 0. Okay, there we go. And then from here we can simplify the exponents. 2 to the power of 2x minus 2x, which is 0, and we're just left with 1. So it's 2 to the power of 1 multiplied by 3 to the power of 2x minus 2x is equal to 0, so we also left with 1. And then multiplied by 5 to the power of 0. So we simplify this, we know that 2 to the power of 1 is just equal to 2, multiplied by 3 to the power of 1, which is equal to 3, multiplied by 5 to the power of 0. Remember that anything to the power of 0 is equal to 1. So therefore, it's just going to be 2 multiplied by 3 multiplied by 1, which should just be equal to 6. Alrighty, so the next example, and this will be the final example, this is what we're going to have also. Our recommendation, do not use the implication arrows that I've been using. This is strictly a habit that I have from university. So equal sign is what you need to use. Right now, let's do exactly what we just did. So in case you were a little bit confused with the first one, let's just do another one for clarity. So let's look at the bases, right? Notice that 9 needs to be converted. 2 is already a prime number. 3 is also a prime number, but 12 also needs to be converted. So therefore, all we need to do is the following. 9 can be converted to 3 to the power of 2, and then we just leave the exponent, 2x plus 1, multiplied by 2, it stays the same, so 2x plus 2, and then at the bottom over here, if we're going to deal with 3 is also a prime number, so we don't have to change that, and then this is going to be 12, which is not a prime number, but 12 can be written as 2 raised to the power of 2 multiplied by 3. I just had to think of that immediately because it was 3 times 4. 4 is rewritten as 2 to the power of 2 in its prime base form. So therefore, it's 2 to the power of 2 multiplied by 3, or 3 times 2 to the power of 2, whatever order, it doesn't matter. You'll probably see it on your calculator. So x plus 1. Alright, cool. And then from here, we just say equals, and then from here, it's going to be, we can now use the multiplication law for this first one here. So it's just going to be 3 raised to the power of 2. If we take 2 and we multiply it into this whole expression, notice that we are just going to get 2 multiplied by, and I'm just going to show you the other one as well, and we're going to also multiply it by this one over here. So it's 2 times 2x, which is just 4x, and then plus 2 times 1, which is just 2, multiplied by 2 raised to the power of 2x plus 2, and then we are going to have the divided by sign over here, and then we have 3 raised to the power of 3x minus 2 multiplied by, and now all we're going to do is just distribute this exponent with the 2 squared and the 3. So I'm going to skip the step of taking the square. Notice that when you do take this exponent into 2 square, the square is going to multiply the exponent that we took in, meaning we are going to have 2 raised to the power of 2x plus 2 multiplied by 3 raised to the power of just x plus 1, because there was no other exponent by the 3 because it was just 1. And now I am going to do the following, right? Notice that we have similar bases within the denominator, meaning we can take those two bases and we can use exponent laws of addition. So I'm going to actually take the ascending order of bases, so you're going to see it like this. So in the numerator, let's start with the 2. So it's just going to be 2 raised to the power of 2x plus 2 multiplied by 3 to the power of 4x plus 2. Okay, and this is all divided by, and if we use the, okay, so let's do 2 first. So we're going to have 2 raised to the power of 2x plus 2 multiplied by, we are going to add these two exponents because they have like bases, which are 3. Okay, so it's 3 raised to the power of 3x minus 2 plus x plus 1. So I'm just going to do it like this: 3x minus 2 plus x plus 1. Okay, and that is what we are going to have. And I'm just going to start doing it from underneath each other because I think it's actually easier like that. Or you know what? No, let's just do it like this because it's still worried about more space. Alright, so I can just go a little bit up now. That's good. So from here, now we can actually split these up, and I will simplify this on the way, so don't worry. So let's just split this up over here and also split this up over here such that we get the following. Alright, so I'm just unpausing here because now I can simplify with you guys. So over here, notice that everything else over here and here and here, they're the same, but here we're going to simplify these exponents. So now 3x and x are like terms, right? They both have x. 3x plus x is equal to 4x. And here, minus 2 plus 1, which they are both constants. So we can say negative 2 plus 1, which is negative 1, right? And then that is what we have. And now we can actually just simplify further. Okay, so let's note that we have the like basis, which is 2, so we can use the exponent law of subtraction. So it's going to be top minus bottom, 2 to the power of top minus bottom, which is 2x plus 2 minus 2x plus 2. Notice that if you didn't have this bracket, you would not actually get to the step where you cancel these two out. Just remember that. You can try it without the bracket and see what it gives you. Does it cancel out, or does it just give you a different exponent? You can try that out. Multiply by 3 raised to the power of 4x plus 2 minus bracket, the bottom, 4x minus 1. Okay, and if we simplify further, notice that this term here, 2x plus 2 minus 2x plus 2, they're going to cancel, and it's going to be 0. Multiplied by 3 raised to the power of 4x plus 2, the negative goes back straight into both those terms, so therefore we're going to have minus 4x plus 1. Okay, so then from here, 2 to the power of 0 is just equal to 1. So I'm saying 1 multiplied by 3 to the power of 4x minus 4x. Those are like terms, so they cancel. Okay, so I'm going to show that step here. They cancel. And then 2 plus 1 is just going to be equal to 3. And therefore, 1 multiplied by 3 to the power of 3, we know 3 to the power of 3 is equal to 9. 9 times 1 is just equal to 9.